slow. Okay, so I'll come to that example after some general thoughts about gradients, Hessians. So what does the gradient tell us? So let me just take an example of the gradient. Let me take a linear function. F of xy equals, say, 2x plus 5y. I just think we ought to get totally familiar with these. We're doing something, we're jumping into an important topic. When I ask you what's the gradient, that's a freshman question, but let's just be sure we know how to interpret the gradient, how to compute it, what it means, how to see it geometrically. So what's the gradient of that function? It's a function of two variables, so the gradient is a vector with two components, and they are the derivative with respect to x, which is 2, and the derivative with respect to y, which is 5. So in this case, the gradient is constant, and the Hessian, which I often call h after Hessian, or del squared f would tell us we're taking second derivatives. That will be, the second derivative is obviously 0 in this case. So what shape is h here? It's 2 by 2, right? Everybody recognizes 2 by 2. This h would have I take the second derivative of that, the first derivative of that with respect to x, obviously 0. The first derivative with respect to y, the first derivative of that with respect to x, y,